Welcome, curious minds. Today we unravel the power that lies within nuclear bombs, a power that can both create and destroy. These formidable devices, capable of altering the course of history, come in two main types: fission and fusion bombs. Each harnesses the energy of atoms, but in dramatically different ways. Fission bombs split atoms apart, while fusion bombs bring them together. So, buckle up as we delve deep into the world of atoms and energy. First, we explore nuclear fission, the process that powers the infamous atomic bomb. Now, what exactly is nuclear fission? Picture a nucleus heavy with protons and neutrons. Sometimes this nucleus is so heavy that it becomes unstable. When this happens, it can be split or fissioned by a neutron. This is the heart of nuclear fission, the splitting of a heavy, unstable nucleus into two lighter nuclei. Now, how does a nuclear bomb factor into this? Well, the bomb is designed to initiate this process in a specific type of atom, namely uranium-235 or plutonium-239. These atoms are fissile, meaning they can sustain a nuclear chain reaction. Once the process starts, it doesn't stop until the uranium or plutonium is depleted. And here's the kicker: to keep this chain reaction going, a certain amount of uranium or plutonium called the critical mass is needed, and thus, a destructive chain reaction is set into motion. Now, imagine this. One single atom triggers a cascade of energy. It's astounding, isn't it? This is what we call a chain reaction. Picture a domino effect, but on an atomic scale. When a neutron strikes the nucleus of a fissile atom like uranium-235 or plutonium-239, the nucleus splits, releasing a tremendous amount of energy and more neutrons. These newly freed neutrons then strike other atoms, causing them to split and release even more energy. And so the cycle continues, creating a self-sustaining chain reaction. But where does the explosive force come from? It's all about the energy. The energy released during fission is immense, and it doesn't stay contained. It rapidly expands outwards, transforming into a shockwave and heat. This is the blast we associate with nuclear explosions. It's a release of energy so powerful that it can level buildings, incinerate objects, and cause widespread destruction. In a flash, a city could be reduced to ashes. But there's another, even more powerful force at play in nuclear bombs: fusion. This isn't your everyday chemical reaction. Fusion is the process where light atomic nuclei combine to form a heavier nucleus. It's the same process that powers our sun and the stars in our galaxy. Here's where two hydrogen isotopes, deuterium and tritium, come into play. When these isotopes are under immense pressure and temperature, they fuse together to create helium and a neutron. This process releases an enormous amount of energy, significantly more than fission. But how is this process harnessed in a nuclear bomb? Enter the dual-stage design of modern thermonuclear bombs. The first stage is a fission bomb which, when detonated, generates the extreme conditions needed to trigger the second stage, fusion. The result? A blast of energy that's millions of times more powerful than traditional explosives. This is where we cross into the realm of the hydrogen bomb. So how does this all come together in a nuclear bomb? Now, to trigger fusion, a fission bomb is used, creating a high-temperature environment necessary for the fusion reaction to occur. It's important to note, fusion releases far more energy than fission. Once detonated, the immediate effects are devastating. A blinding flash, a destructive shockwave, and intense heat. But the long-term effects, like radiation sickness and nuclear fallout, can linger for years, even decades. The result? An explosion of unparalleled force. Nuclear bombs have, unfortunately, left their mark on history. The devastating impacts of Hiroshima and Nagasaki during World War II serve as chilling reminders of their destructive power. But it's not just about historical events. The potential for future devastation is a stark reality we must confront. In this journey, we've delved into the science behind nuclear bombs, from the splitting of atoms in fission, to the fusion of hydrogen isotopes, and the chain reactions that unleash unimaginable energy. But more than understanding the mechanics, it's crucial to grasp the global impact of these weapons. Nuclear arms have the power to obliterate cities, alter climates, and cause long-term health problems, among other catastrophic consequences. This understanding underscores the importance of disarmament efforts and treaties aiming to control and eventually eliminate these weapons. As we've seen, the power within these bombs is immense, but it's a power we must strive to contain. For in the end, the future of our world may depend on it.